Dear students, today we are going to discuss about solar PV system. The outline of the discussion will be as first of all we will discuss about the requirement of renewable energy sources, then solar power electricity generation, then we will discuss about factors for choosing the solar power generation, then electricity generation from solar cell or the PV cells, then we will discuss about solar PV cell, PV module or panels and PV arrays. It will be followed by components of solar electricity generation and then different type of solar electric systems. So first of all, the requirement of renewable energy sources. What is the requirement? As we know that in the current scenario, the requirement of electric energy is increasing day by day, and we are having the conventional sources which are using, most of them are using the fossil fuels. And as we know that there are two disadvantages of fossil fuels. One is that they are producing the pollutants, and other we are having limitations of fossil fuels, that they are going to be finished after some time. So we should go for such a sources which can produce the energy for a long time, that are known as the renewable energy sources. So we must concentrate on the renewable energy sources. The solar power is one of the renewable energy sources which we can consider. Now, why to consider the solar power generation? What are the factors behind choosing the solar power generation? We know that the solar energy is freely available to us, and we can easily convert the solar radiations into the electricity. Secondly, we know that less installation time is required for installing a solar power plant as compared to any other conventional plant. Third, the running cost for the solar power plant is very less, as there is no fuel required. It requires only the solar energy, and most important, it is pollution free. We know that no pollutant is produced during the solar power generation. Now, how the solar electricity is generated? Solar power is the conversion of sun radiation into electricity through the use of solar photovoltaic cells. This conversion takes place in solar cell by photovoltaic effect. The solar power generation is most efficient route of power generation because it takes a minimum number of steps for producing electricity. Basically, there are two ways by which the solar energy can be converted into the electrical energy. One of the method is converting the solar radiations into the heat, and this heat is further used for production of the steam, and the steam drives the steam turbines. This method of power generation is called as solar thermal power generation method. The second method, the solar energy is directly converted into electricity using solar cells or the PV cells. These PV cells are made of semiconductor materials. Now, a PV cell or the solar cell is a semiconductor device that converts the solar energy directly into the electrical energy without going through any other energy conversion step. This conversion takes place by photovoltaic effect, and hence they are called as photovoltaic cell. It generates voltage at its terminal when sunlight incident on it. The way and the amount of power generated by solar cell depends on sunlight falling on it. This also includes some factors such as intensity of light, angle at which light falls on it, area of the cell, etc. Irrespective of the technology and the material used, every solar cell has two terminals. One is positive terminal, other is negative terminal, so as to take electric current from it. Basically, the sunlight consists of the bundle of photon, where each photon has finite amount of energy. To generate electricity from solar cell, these photons must be absorbed by the solar cell. The energy of photon and also the band gap energy of semiconductor material decide the absorption of the photon. When solar panel absorb the photon in sunlight, electron hole pairs are generated. When the solar cell is connected to the load, electrons and the holes at the junction are separated from each other, where the electrons are collected at negative terminals and holes are collected at positive terminals. Thus, the electric potential is built between the terminals and hence voltage is developed across it. This further drives the current to the DC load, inverter or battery charging circuit. Now, what is PV cell or the PV module or the panel? A single solar cell of 4 cm square develops a voltage of 0.421 volt and can produce 0.7 watt power when exposed to the sunlight. We can see here this is a type of a solar cell. When this can produce a voltage of 0.5 to 1 volt and have the capacity to produce approximately 0.7 watt power, approximately we can say. But for the higher voltage use, this single set cannot be used. So these cells are connected in series and parallel combinations to form a module like this. This is called as a module, solar PV module or solar panel, where a number of cells are connected together in series and parallel combinations. Further, to obtain higher voltage and higher power rating, these modules can also be connected in series and parallel combinations as per requirement to form solar PV arrays. So we can form solar PV arrays by connecting the modules with series or parallel as per our requirement. Now, component of solar electricity generation. So we can see a diagram here. This is a type of solar electricity system. Basically, this is off-grid type or stand-alone type, in which we can see here a solar array is there, which is generating the DC current, and this DC current is charging this battery with the help of a charge controller circuit is there, and then the inverter is connected. because this DC is converted into the AC with the help of inversion procedure, and we are having AC load at our homes. So basically we can see here that the various components, the solar array is there, battery is there, charge controller is there, inverter is there, and the load is there. These are the basic component of a solar electric system, basically we can say. Now, as we discussed earlier, that cells when combined together can form solar panels, and when the panels are combined together can form the array. Now, as per our requirement, we can connect the panels in series or parallel combinations. Suppose if we are having a 12 volt and 12 watt solar panels supplying 1 ampere of current, and we want to have 48 volt 48 watt 1 ampere current through these panels, then these panels can be connected in series like this. All the 4 panels are connected in series, so the current will be the same and the voltage will be the additive. So the 4 panels are connected, so the overall voltage will be 48 volt and the overall power will be 48 watt. Now if we want to obtain the 4 ampere current, then we have to connect all these 4 panels in parallel. Then when we are connecting all the panels in parallel, the voltage will be the same, that is 12 volt, power will be 48 volt, and the current will be 4 ampere. So in this way we can connect the solar panels to form solar array as per our requirement, either into the series or into the parallel combination, or combination of series and parallel combination as per our requirement. The second important thing is there a battery. When we are using off-grid type of system or standalone system, the battery is very important, because we know that the solar energy generation depends upon the strength of the sunlight. So in order to provide a constant power to the load, a battery is very necessary. And third important component is the controller. Basically it is charge controller. It regulates the flow of current in and out of the battery. If the generated current overcharges the battery, it leads to the damage. So there are two things, either the overcharging or fully discharging of the battery. Both the cases are harmful for the battery. In that case, the controller protects the battery from damaging. In addition, it also gives the alarm if it is not functioning properly, the module is not functioning properly, then the controller also gives the alarm. The inverter, as we earlier discussed, that the generated power is in the form of DC, but maximum loads at our home are type of AC, so this DC is required to be converted into the AC, so we require inverters. Now a different type of solar electric system. One we have discussed earlier, that is off-grid or stand-alone solar electric system, which we have discussed here. This is the diagram for off-grid or stand-alone solar electric system, in which the solar energy which is generated by the solar array is consumed at the home only. This energy is not fed back to the grid, or the system is not connected any of the grid, so it is called as off-grid or stand-alone system. Second type of system is grid connected system. So we can see here one grid connected system. This is the type of grid connected system in which a solar array is placed here, which is producing the electricity. Then electricity with the help of a control panel flows through and supply is fed back to the grid like this. In these type of solar arrays, the micro inverters are placed together with the array. Those micro inverters convert the DC into high voltage AC, which is suitable for connecting supply directly to the grid. And one control panel is there with the help of which the supply to the home or the organization can be continued. So here both the purposes are fulfilled. Supply is given to the home or the organization, and the remaining extra supply is given to the grid. We can see one more diagram here. The panels are there, then the isolation and DC AC inverter and the filter circuit is there, household sockets are there, electric meter is there, and electric grid is there. The power is fed to the electric grid. In these type of system, no battery is provided. There is no requirement of battery. One drawback of this type of system is that whenever the grid supply is off, the home or the household supply also get turned off. Because if this system won't stop, current flows back into the grid could lead to serious faults. Then central grid connected solar electric system. When the system is very large, we can say that 100 kilowatt system or 1 gigawatt system is there. That system is directly connected to the transmission system and is said to be a central grid connected system. Otherwise, it is same as a grid connected system. Next is grid fallback solar electric system. In this type of systems, a battery bank is connected. It is combined. It is combination of grid connected system with a bank of battery. In this solar array, generate the electricity, which in turn charges the battery bank, and battery power is then running the inverter, which drives the load through the inverter. When power in the batteries is not enough to drive the load or battery is discharged, then the system automatically switch to the grid power supply. And when the again battery started to charge, and when battery is fully charged, then it is automatically disconnect the grid power supply and supply is maintained with the help of the battery. This system doesn't sell any power to any electric utility, and overall power generated used for domestic or the residential purpose. Thank you.